So let's see what we did last week. So we discussed about sectional views and why we use them. And then we discuss about the measuring cutting plane and which sort of lines are using. And also we discuss how we generate sectional views. And what sort of errors we can do and how to avoid them. And also how do we place section lines correctly. And then we discuss about which sort of patterns we are using for each material. And then we discuss about half sections. How do we use them for symmetrical objects? And also offset sections. And also aligned sections. And we discuss which sort of features we are section and which like the bolts, nuts, rivets, screws, etc. we are not going to section. So then we discuss a little bit about SolidWorks, and I gave you an introduction, how to create a part, and also I discuss a little bit about the three environments: part environment, and there are assembly environment and drawing environment. So those two I will give you introduction later. So today we are going to discuss about dimensioning. A dimension is used to define a form, size, orientation, or location of a feature or part. So it could be a value or values or mathematical expression provided in appropriate units of measure. So there are two classifications of dimensions. One is size and other one is the location. So size dimensions are placed directly on a feature to identify specific size. For example, a circle, your diameter would be a size dimension, right? And the next one is location dimension. Let's say you have a square like this, and then your center point dimension from this edge to here, and from here to here. So that will be location dimension. So it is important that you have to efficiently combine shape and size description so that your drawing is easy to read and understand. Right. So any questions on this slide? The size dimension and location dimensions.
Sir,
Yes.
මේ පොඩ්ඩක් වැඩි කරනවා මම නෙට්වර්ක් එකක් ඇවිල්ලා ඒක ස්ටක් වෙලා තිබ්බේ.
Oh.
මේ දැන් ඔය ඩිමෙන්ෂන් තියෙන ටික පොඩ්ඩක් කියන්න.
Right. Okay, so dimension is used to define form, size, and orientation or location of a feature or part. So dimension can have a value or several values or mathematical expression provided in appropriate units of measure. So there are two kind of dimension types. One is size and other one is location. So size dimension is placed directly on a feature to specify a size. So for example, it could be, let's say you have a circle and your diameter dimension is a size dimension, and location dimension is where you place the circle inside of another part or another feature. So your dimension for your center of the circle, from, let's say, from this edge to here, is your location dimension, same as other way, right? So it's very important to efficiently combine shape and size description so that your drawing is easy to read and understand. So there are a couple of dimension symbols. So you may have already know that these symbols, but I will go through from the beginning. So let's say you are going to define a diameter. So you have a circle like this, and so when you want to define diameter, first you have to use this symbol. Then you have to write your value. Let's say 10 millimeter diameter. First you draw the symbol and then you write your number. And let's say you have to define a radius. Let's say you have some curved edge like this, right? Then you are not going to define a diameter. You are going to define as a radius. So you have to write R and then your value, R10. So these are most common dimension symbols, these two, right? Let's say so let's see what is spherical radius and spherical diameter. So let's say you have so I'll draw it a little bit in 3D. You have a cylinder like this. At the end you have a sphere. That's the other edge. So you have a cylinder, at the end surface you have a sphere, right? So there in front view it's look like this, and also other, let's say, top view, it looks same, but you can define one view and you can just mention SR, says spherical radius, say 10. Let's say you have the same kind of object, but you have like something like this. Then you can define spherical diameter like this, because in spherical radius, let's say object like this, and you have a spherical shape like this. In this case, you can define spherical radius, but if you have a sphere like this, then you can define spherical diameter. And then there is other one called control radius. So normally we define radius, right? So if you can see here, its radius is 0.75 or 0.75, right? And also your tolerance is plus or minus 0.01, right? So if you actually manufacture it according to this tolerance, your minimum radius would be either 0.74 or 0.76, right? Because you have 0.01 tolerance value. But if you actually see the microscopic view, your actual shape something like this, not a perfect circle or here, right? But in control radius, it will be a smooth one, right? Not like this kind of zigzag line, right? That's called control radius. So in engineering drawings, most commonly we are going to use these two. But if you see this kind of symbols, you have to know what it is, because in the industry you may get some engineering drawings from a supplier, right? So they might be using these kind of symbols. Then you have to know the meaning of those. And then last one is this X symbol. So it means number of places. Like for example, in this figure, so from this hole to this hole, angular dimension is 90 degrees, right? So likewise you have all 4 holes around, but instead of placing all 4 dimensions, you can place 4 into 90, right? So that's easy to use. Otherwise, if you use all 90 degrees here, so it's kind of not nice, right? So similar features, similar dimensions, you can define like this. Any questions on dimension symbols? Okay. So in dimension, there are specific things you have to look for. So in a typical dimension, for example, this is a size dimension, this one, right? So in the dimension, you have extension line like this. And also you have 2 arrows. So arrowhead is like this, or it could be like this, right? If you have like a very small space, small part, right? Let's say you write 100 and there is no space for you to place the arrowhead. In that case, you can define it from the outside, then you can place the text inside, right? And this is the dimension text and dimension line, and also there should be a small gap between your part and the dimension. This is called extension line offset. If you do not place this offset, then your dimension look like this, and then your manufacturer will confuse. He cannot understand whether it's coming from the, if it is a feature of the part or not, right? So you have to define a small gap. And also after the arrowhead, you have to define little bit of extension here, like this. So typically 2 to 3 millimeters would be okay, right? So here you can see that how you define a diameter dimension and a radius. There should not be any space between phi symbol and the number, right? And also radius, there should not be any space, right? No space, right? Next, you can define angles like this. Same way, 2 arrows and your angular dimension. Now, if we talk about these center lines, you have to remember one thing. So normally center lines are defined longer line, smaller one, longer, right? So when you place this center line in a center point, you have to make sure that in your center, 2 short lines intersect at the center point, right? Then you have longer line and longer line there, right? So if you place longer line, shorter line, and you define in the vertical side, shorter line here and longer line here, like this, then it's wrong. You have to make sure that 2 short lines are intersect at the center, right? And also there should be a space in between this shorter line and longer line, right? So that's why I discuss in AutoCAD the LT scale command. How do you define the space? And also after the feature, you have to have a little bit of extension in the center line. So any questions on this slide? So now we are talking about how do we place the dimensions. So first we will discuss about unidirectional dimension. So it is commonly used in mechanical drafting and for manufacturing. So that's how we are going to place our dimensions, right? So unidirectional dimensioning requires that all numerals, figures, and notes to be lettered horizontally and be read from the bottom of the drawing sheet. So if you consider this figure, so all your dimension text are horizontal like this, and also your vertical dimensions, the text is horizontal, right? If you place the drawing view like this, you can all your dimension text are horizontal, right? But if you talk about align dimensioning, the next topic, your and the vertical dimensions, you can see that your text is aligned to that, right? So this align dimensioning we commonly use for civil and structural drawings, but in certain cases, in certain companies, they use this for mechanical drawings as well. So any questions about unidirectional dimensioning and align dimensioning? Okay, no questions. So next we are going to discuss about rectangular coordinates. Let's say you have a shape like this and you have several holes in that. So if we are going to place dimensions in a normal way, so then let's say I start from this surface and then I will have to dimension here, right? From here. So each hole has two location dimensions, right? X and Y. Likewise, right? And also diameter dimension, right? So imagine you have very large plate containing several hundreds of holes, different diameters here and there, right? And then if you are going to place dimension, there will be a huge mess. So you have several dimensions like this. So then it is very difficult to understand and identify the features, right? Because if you have two holes very closer, then your dimensions is almost similar, right? So in that case, to avoid that and make clear drawing, so we are going to use this rectangular coordinate method. In this method, we have to define our 0, 0 point, our reference point. So in horizontal side, so this is our reference. In the vertical side, this is. So altogether, this is our reference point, right? Then we can define our dimension like this. So this is 0 and hole A location is 15. You are not going to place any arrows and dimension lines. So you just draw a line like this and put 15. And for the B, it's 57. And for the vertical side, 14, 38, 50, like this. So in this way, it is easier to identify. And you have to have a table, says hole symbol A, B, C. And your hole diameter. So hole A, hole A diameter is 6. So you don't have to put the diameter here, right? So similar way, if you have two similar holes, you can define same symbol, hole B, diameter is 9, quantity is 2, right? Similar way, you can define C. So any questions on this rectangular coordinates? Okay. Next, we are going to discuss about tabular dimension. So it's kind of same, but little bit of extension compared to the rectangular coordinates. In the rectangular coordinates, we define the location dimensions in the drawing itself. So rectangular dimension, you can use, let's say you have fewer number of holes. But if you have large number of holes here and there, then placing location dimension also will be a difficult one, right? So in that case, you can define your XY location in your table as well, and also the depth of the hole. So similarly, you define your X dimension like this, Y is like this, your reference point is here. So you can define A1 here, and your X and Y dimension. In this case, compared to the previous one, you cannot define both holes at once, right? Because your X and Y locations are different in those, even though your hole diameter is same. Right? Let's say B1 diameter is 9, B2 also 9. But your B1 is here and B2 is here. So you have to define which is X coordinate and which is Y. And also you have to define if it is through hole. Through hole means hole is all the way from top to bottom, right? But in the B1, it is 9. So your XZ dimension, the depth is 16 here, but your hole is up to 9. It's halfway, like this. Likewise, you can define this. So this is particularly used when you do a CNC machining, where you do the programming. You use programming to do the machining. So anyone knows about CNC machining? Okay, no one. So CNC, we have to define the program. For example, if you do in the 3D model in SolidWorks, and there is a software called SolidCAM. So we can define our part, and we can define the whole location. Like if you have a drawing like this, and then you can define your locations in XY coordinates. Then when you do the machining, your tool will move to the XY coordinates with the reference to this point. So you have drilling operation, then it comes to here, and then it will count from this point and goes, let's say A1. So X dimension is 15. So it goes this way 15 and Y direction 14, and do the drilling operation. So any questions about tabular dimension? Any questions? No questions. Okay. So now we are going to discuss some fundamentals. So when dimensions have numerals containing decimal points, the decimal points should be uniform throughout the drawing. So let's say you have a cylinder, you have a front view like this, and you have a side view like this, and you define this diameter is 10.5, and then you define this dimension, its length, let's say 15, then it is wrong because you have used one decimal point here, but you didn't use that here. The correct way is 15.0. So if you use, let's say if you have another dimension in this drawing, 9.25, then you have to have 10.50, and also this dimension should be 15.00, right? But if you, let's say you don't have like dimension like this and you have defined like this, right? It's also wrong because you are putting unnecessary zeros. That's also you have to remember. Any questions on this, how to place decimal points? No. Okay. Now we are going to learn about arrowheads. So in the dimensions, so one of the main component is this arrowhead. So there are a couple of arrowhead types, but this is the preferred one, right? So in that case, so there is a ratio defined in the arrowhead. So if you have 1 millimeter arrowhead like this, the height, then you have to use 3 millimeter here, right? Let's say you use arrowhead like this, it's wrong. And also if it is too lengthy like this, it's also wrong. So there is a standard ratio, 1 to 3. So these kind of other optional arrowheads we are not using, but in some standards, some companies, they prefer this. So when you go to work, you learn this preferred method, but when you get a drawing from a supplier, and you might see this kind of arrowheads, right? So in the positioning, as I mentioned, so your text could be like this or like this because you don't have enough space to place these arrows, right? In certain dimension standards, so your text look like this. In certain types, your arrowhead look like this, and your text is on top of the text dimension line like this. This is also correct. This is also correct. But these two are two standards, and you have to use one standard in your drawing. Okay? Don't use both, right, at once. Any questions about this slide? Okay. So when you place the dimensions in your first dimension, you have to, for example, you have to place 10 millimeters from your object, and then the next one you can place little bit closer, which is 6 millimeters, right? So these are standard values, but you can change them. You can change little bit, but do not make this closer here, right? Too much closer is not that good image. You have to clearly separate the dimensions from your object, right? And also when you place your diameter dimensions, do not put inside the object, right? Do not put 512 here, right? It's wrong. You have to place the dimension outside from your object. Any questions? Okay. So let's see how we can correctly place the dimensions and what are the errors we do. So in the first right hand figure, so this person put their shorter dimensions like this and your lengthier dimension much closer to the object. So that's wrong. It should be like this, right? You have to define your smaller dimension at first, then closer to the object, and your overall dimension or lengthier one should away from the first dimension, right? And also I explain you this is also wrong because you have placed a dimension within the object, so that's also incorrect, right? So in the third one, you have defined a set of dimension from this side and your overall dimension to that side, so that's also wrong. So it should be in the same side, right? In the last one, let's say you have a front view like this and your side view like this. Although you see your feature in the front view, you have defined it as a hidden here. You place the dimension. That's wrong. You can place the dimension in the front view where your feature is clearly visible. Right? So any questions about this slide? How do you place the dimensions correctly? Okay, everything clears, right? Okay. So next one, we are going to discuss about several types of dimensioning styles. So the first one is chain dimension. So it is also known as point-to-point dimensioning. Right? So each dimension is depend on the previous dimension or dimensions. For example, this figure. So you have defined 25 here, the length, and the next feature you have defined from here, right? So let's say you have a tolerance plus or minus 0.5 2, right? Because you cannot manufacture to an exact dimension, right? Your machine shop will have some kind of tolerance in their machines. So although you define 25, you might get 24.8 or 25.2 because you have plus or minus 0.2 tolerance, right? So if you define like this, you have defined the 25 here. Let's say you got 25.2 in the actual part, and since you are using chain dimensioning, so you have defined this feature based on this. So you get another 25.2. Imagine like this, right? So if you measure from here to here, it is 50.4, but your ideal dimension is 50, right? But your tolerance is adding up each other, right? By defining like this. Right? You have to be careful when you use dimensions, right? Although your dimension is 0.2, you define your dimension such a way that your tolerance are added up each other, right? Let's say you get 25.2 first, and then you get 24.8 as next one because you have 0.2 tolerance. Then you are getting 50, right? So that's by chance you get 50, the correct value. So we cannot expect that to be happen every time. So any questions on this change dimension? Okay. So next one is baseline dimension. So it is common method of dimensioning machine parts whereby each feature dimension originates from a common surface, axis or center plane. So you dimension the same figure with respect to this surface, this line. So 25, 50, 75 like this. Same way in the vertical side. 8, 16, 24 like this. So in this method, your tolerance buildup is less compared to change dimension. Because you have 25 here, you might get 25.2 here. Since you define from this surface, you might get 50.2 here. So likewise, but if you change dimensioning, you are adding this tolerance and then it will adapt to here as well. So any questions about this? No questions. Okay. So next one is direct dimension. So it is applied to control the size or location of one or more specific features. So this is the least tolerance accumulation method. So let's see this figure. So the same part dimensions using 3 different styles that I discussed. Okay. So first I discussed about the chain dimension. So where you define like this, you are adding up all the tolerances, right? So most tolerance accumulation between x and y. So let's say y is here and x is here, right? This. Let's say if you use baseline dimensioning, so your base is like this, right? Your reference line, and then you start the dimension from that surface. If you consider x and y points, these 2 points, less tolerance accumulation compared to the chain dimension, right? Because you have 10.2, and let's say you got manufactured exactly 36 here, right? So then you have a certain tolerance, right? Because you should get 26 from here to here, right? If you perfectly manufacture it, since you have 0.2 additional here, then you get 25.8 here, right? Since you have 10.2 additional, right? So in the direct dimensioning, you can define x and y points like this. You are placing a separate dimension, right? Because you have to, let's say in this part, distance between this x and y is critical, so you place a dimension there. So then you don't have tolerance build up. Okay? It could have a default tolerance. You can get 26.2, right? But you are not getting other than this tolerance because you are not referring to other dimensions. So this is the least tolerance accumulation between x and y. So when you place these dimensions, one thing to remember, let's say you use chain dimensioning and you define all the length like this, and do not put a total value like this, right? Total is 36, right? You are not over defining, right? So if you really want to have overall dimension, then you have to use parentheses like this, 36. Then your manufacturer will notice that this 36 you have placed as a reference. Sometimes we are using this in order to get the overall length and width, because you have to get the material to machine this part. So in order to do that, if you are not placing this reference dimension, then your manufacturer will have to add up all the things, right? 10, 10, 10, and 6 here, right? So either you can place 36 here like this, you can omit this one, 10. You can define only 3, only these 3. So any questions about this dimension styles? No questions. So next one, we are going to learn about nodes. Nodes are type of dimension that generally identify the size of a feature or features with written specification. that are more detailed than a numerical value, right? Let's say you have a hole, right? And then you define the diameter is 10, right? And if this hole is all the way to the, let's say if it is a through hole, then you type THRU like this, capital letters, 5, 10, 5 symbol and 1 0 and THRU. You have to have one space here. So there are two kind of nodes. One is local nodes and other one is general nodes. So this is a local node where it is connected to a specific feature on the views of a drawing. Right? General nodes you are going to define in your title cage, title block. You have some space here. You can define, let's say, general tolerance, and you are going to define standard units, millimeters, inches, or whatever it is, right? So those are general nodes. These are local nodes. So node is kind of written specifications, right? That are more detailed than a numerical value. So any questions about nodes? Any questions? Nothing. Okay. So next we are going to learn how to dimension hole. So that you have to define like this 5 symbol and the dimension value. But when you place the dimension, it should go your arrowhead point to the center, right? It should not like this, right? This is wrong. So when you do your drawings manually, you have to make sure that. But when you use the software, it will automatically points towards the center. So when it has a true hole, as I explained you, you have to write this THRU, through hole. So when you manufacture a hole, right? So if you see, the drill bits are used to drill a hole. So normally drill bit have a conical shape like this, right? You cannot have a hole exactly flat like this. Let's say you have a part like this, material here. You cannot have a hole like this unless you are doing a special operation. Right? There is a special operation to do this, right? But it's kind of time taking. Unless you have specific reason. So normal drill holes like this. You have conical shape because you are using a conical shape drill bit like this. So when you define the depth, you have to define up to here. This is your usable depth. This area you cannot use. It's coming from your drill bit. So when you define the depth, you can write like this, your diameter dimension like this, and your depth symbol is like this. How much depth? 12. Right? If it is through hole, then you don't have to write this. just type THRU. And also when you place the dimension like this, if you don't like, you can omit this and you can define the actual dimension in the view like this, right? In that case, you have to have a little break here in the section lines, right? Do not intersect like this, right? When you do the manual drawings. So this type of dimensioning is particularly useful when you are not going to place the dimension in your sectional view. You can just define this dimension in your front view. So then your manufacturer will know that you have 15 diameter hole, your depth is 12. No need to specially mention that if you're using this method, or else you can use this one, that dimension diameter here and depth like this. Any questions about dimensioning holes? No. So similarly, there is a term called counter bow. So it's kind of hole, but little bit modified hole. So when you have bolt and you are going to assemble two parts together, right? So either you can use a hole like this, or else you can use a normal hole, and your bolt, the head of the bolt is coming out of your part like this. Okay? So this is like not professional. So in order to hide your head of the bolt, you can have a hole like this, and also drill like this. So this is called counter bow. So your bolt head or other fastener can be recessed. Okay? So in order to define that, you can define your smaller diameter like this and use this symbol like this, right? And you have to define that diameter and also depth of that diameter, right? So in this case 7 diameter is here and 15 here, and depth of the 15 is 6 here, right? So this is called counter bow. Any questions on this? No questions. Okay. So when you use this kind of dimensioning, you have to be very careful. So if you define like this, your smaller diameter like this and 5 symbol here and 15 here, it's wrong. It should be here, right? Or else like if you can use your depth dimension in one line, or you can use as 2 lines. That's correct. This one is correct, these two. But you cannot move your diameter dimension here, right? So similarly, there are kind of screws like this. you have already seen this kind of screws. You have conical shape in the screw. So you have a screw like this. So this kind of screw, if you place in object, drill this way, see, then your screw head come out like this. In order to flush this surface to here, you can drill like this angle so that your screw is aligned with your object. So that's called countersink. So you can define this using this symbol, V-shaped symbol. So it should have a 90-degree like this symbol, and 16 diameter is here, that is this diameter, and 9 diameter is here, this one, right? And 82 is your actual angle, right? From here to here, but in your symbol it should be 90, right? This angle, when you draw it, it should be 90, because if let's say you have something like 60, and then if you draw it like this, it's wrong, right? Even though you have a 60, you have to draw the symbol as 90, and 60 should be come here, right? Any questions on countersink and counterbow dimension? No questions. Okay. Right. So when you're dimensioning repetitive features, you don't have to dimension each and every feature. So let's say you have a shape like this, and then from here to here angle is 60, and then you don't have to put 60 here and here, right, every time. So 6 into 60, right, like this. And also you can define length of this teeth here 6, and you can put a note 6 times, 6 and X symbol, so that you don't have to put 6 every time. Same as here, 4 times this diameter. And also let's say you have a similar circles, right? So here it's diameter is 10 and this is 10.2. So it is, you can define this as y, right? So it says 4 times 10.2 diameter, indicated y. So y is this, these 4y. Other ones it's 10. Likewise, you can use repetitive features dimensioning. So any questions? Okay. So the dimensioning is very important, because if you do not properly place the dimensions, you might manufacture different type of part. Okay. Okay, so in this kind of figure, rather than using coordinate dimensions that rectangular coordinate dimensions. Like let's say you have a hole here and hole here. So what you can do is you can define hole location from here and here. Right? But rather than this dimensioning, you can use polar coordinates. You can define the angle. Right? So that way it is easier. So with reference to the center point, you can define 45 like this. And also your location dimension from the center, you can define 41. You have a center line goes through these holes, and your angular dimension is 45, right? Because if you use rectangular coordinates, you have to define the location by two dimensions, x and y. Right? In the polar coordinates, you have to define it from the center, right? So if you consider this hole, so if you define this angle 45, right, and you can have a center line like this, right? But you have to define the other dimension, because if you draw a line at an angle of 45 and then your circle might be here, here, in this line, anywhere, so you have to define with reference to the center point. So that's why we define this 41. So either you can use a radius, but preferred method is diameter. Either you can use R 20.5. Right. So any questions on this polar coordinates? No questions today, right? Okay, so next, some of the students asked me, how do we arrange the drawing layout? Right? So since we cannot do the actual manual drawing, but I can give you the instruction how to do it. So I taught you about how to place, how to define the front, side view, and plan view. But I didn't explain you how do we place them within the drawing format, right? So this one, this note I got it from the university when I learned engineering drawings. So can you see the text, or I can enlarge it a little bit? Can you see this text here? Can you see that text, or I can enlarge? Anyone tell me?
Oh, can't see it properly.
Right, okay. So I think it should be visible now.
That's it. Good.
Right, okay. So imagine you are going to draw this figure, right? and your front view is looking from this side A, right? And your other side is B, right? Side. Okay, so the first step, do not draw directly on the paper, right? Just roughly draw it on your rough paper, not all the features, right? The outline, draw it on a rough paper. Don't spend too much time on this rough sketch, right? So when you get this kind of problem, so you just have to imagine what will be your front view and what will be your side and your top view. Okay? So just draw it on the rough paper and see how it looks, right? And put the overall dimension only, right? Length, height, and width, right? So next, when you, let's say, you cannot at first define I'm going to use A4, A3 or A2. You cannot do that. Right? You have to do it in the reverse way. So first you have to think about the front view and the other orthographic views, and then you have to allocate some space for the dimensions and other nodes. You have to roughly allocate some space, and then you have to think whether I can put this on A4 or A3, right? So that way, not the other way. I am going to use A4 and somehow I will fit all three views, all the views in the A4. That's not going to work, right? If you do so, then you anyway you have to do the views, no? So if you don't have enough space, then you are compromising the space between the dimensions. Then you have to place the dimension very tightly. So that's not good, right? Okay. So after you selecting a paper, let me show you rough paper like this. Let's say you have say A3 paper, right? This note I got from the textbook, right? But in the textbook they have used this total drawing area like this, right? They have allocated this area for called revisions, right? So since we are not going to use that, so you can use entire area like this as your total drawing area. So since you have done the assignment 2, you can define your total drawing area, right? So for example, let's say you have drawn your rough sketch like this, right? Just roughly put few dimensions, right? So they have mentioned that how to select the drawing paper, right? So first is width of the drawing area is millimeters here. So the front view width, so it's 55. So it's 55 here, right? Then space from front view to the first dimension. So it's 20, and next 10. And then you have open space 20 here. So likewise, you have to roughly define how much space do you need, and then you have to define right side view depth here. It's 12.5. So drawing area total is, in this example, 174.5. So round up 148. So likewise, before you placing the views, you need to have a better idea how my front view is within this boundary. So my side view is like this. So that idea you have to have before you draw it, because when you draw it in the manually, you cannot erase and draw it again. In the software, you can move here and there, and you can change the paper size. If it is not enough, you can change it. But when you do the manual drawings, you cannot change it. Right? If you draw it, it's there. Because when you draw a front view halfway, you realize that you don't have enough space. Then you cannot erase it and draw it. So it takes a lot of time. So when you put the dimension, you realize, oh, I don't have much space. Then you have to draw it again in a bigger paper. So manual drawing is very tricky, and you have to imagine all the things before you draw it, right? So as a step 1, sketch your orthographic views where you intended drawing them. In your rough sketch, indicate overall length. So apart from your initial rough sketch, you are going to place the outline. So your front, let's say your front view like this, you roughly draw it very lightly, right? Outer dimensions, outer sizes, right? And position. So that you have enough space from here, so between these, right? And also you have to draw the center lines initially, right? Here. So you draw the center line from this view, and from the side view also you can see the center line as a hidden, so that you have to draw it in the proper format like this. Lengthier one, shorter line, and again lengthier, like this, right? In the step 2, so draw all the circles and arcs based on the center lines, because it is easier to draw circles and arcs and then draw the lines from there. If you draw lines and then do the circle, it's a bit hard. For example, here, so you draw this arc first, and then you can draw your other lines like this. If you draw this first and then draw here, it's difficult, right? And then as a step 3, you can draw other features, right? All the other features, but very lightly. So when you draw it, you have to align, right? As I explained you in previous lectures, this cylindrical part should align in the other view, right? So lightly draw it, right? And also do not draw all the features in one view and move it to other. That's wrong. So when you draw it, that feature, also do the projection in the other view, right? Do not just complete one and then go to other one, right? In the last step, at the hidden lines and about unnecessary construction lines. Right? Since you have some unnecessary extension lines, since you have drawn it lightly, you can erase it easily. Do not do it with pressure, right? So after checking the drawing carefully, right? Darken all the outlines using a soft pencil. Then add dimensions, so titles, notes, main title, scale, projection symbol, everything. You can do it. So this is how you draw a engineering drawing, right? Manually. In software, it is a bit easier. You can move the views here and there. You don't have enough space. So any questions about the steps of placing the views?
Hello, sir.
Yes.
පොඩ්ඩක් step 1 එකට යන්න sir.
Right. Okay.
Step 1 එකේ එහා පැත්තේ ඒ කියන්නේ main drawing එක තියෙනවනේ sir. දැන් ඔය sir place කරලා තියෙන්නේ side A වලින් බලලාද side B වලින් බලලාද sir?
කොයි එකද?
මේ ඇඳලා තියෙන drawing එකේ
මේක A. මේක A.
එතකොට සර් ෆ්‍රන්ට් එකේ යටට ප්ලෑන් එක එන්නේ නැද්ද සර්? හරි. සයිඩ් එකේ යටට ප්ලෑන් එක එන්නේ.
right. ඒක මම කියන්න. ඒක තමයි දැන් අපි මේක දැන් මේක A front නේ අපි ගත්තේ.
ඔව්.
හරි. එතකොට අපි use කරන්නේ first angle projection. හරිද? එතකොට අපි කටපාඩම් කරන්න අරකයි හැමතිස්සෙම front එකට යටින් ද මේක එන්නේ එහෙම කියලා. හරිද? එහෙම කටපාඩම් කරගන්න එපා. දැන් මම front view එක A කියලා define කරලා මෙතන ඇඳලා පස්සේ මම මේ side එකෙන් බැලුවාම මට පුළුවන් ඕන නම් අනිත් side එකෙන් බලන්න මේ පැත්තේ. එහෙම බලන්න නැත්නම් මොකද features ටික පේන්නේ නැහැ මේ පැත්තෙන් බැලුවා. ඒ නිසා මේ පැත්තෙන් බලන්න. right? එතකොට මගේ first angle projection එකේ මම මෙහෙම project කරොත් මගේ front view එක මේක නම් මම මෙහෙන් නම් බලන්නේ මම ඒක place කරන්න ඕනේ මෙතන. right? මගේ side view එක. හරිද? හරි. එතකොට මගේ front එක මෙතන මගේ side එක මෙතන. හරි. එතකොට මගේ top view එක තියෙන මම උඩින් බලන එක. ඒක හැමතිස්සෙම front view එකෙන් තමයි project කරන්නේ මෙතන උඩින්. හරිද?
front එකට යටින්.
ඔව්. views එන විදිය කටපාඩම් කරන්න එපා. දැන් සමහර ඒවල front එක මෙතන ඇවිල්ලා plan එක මේ top view එක මෙතන එන්න පුළුවන්. හරිද? මොකද ඔයා මේ පැත්තෙන් බැලුවොත් එතකොට ඔයාගේ front එක වෙන්නේ මෙතන. ඔයාගේ side එක එන්නේ මෙතන. හරි? මේ front එක මෙතනයි side එක මෙතනයි කියලා කටපාඩම් කරගන්න එපා. front එක තිබ්බට පස්සේ ඉතුරු ටික එන විදිය theory එකෙන් හිතා ගන්න. මොන projection එකද පාවිච්චි කරන්නේ? normally අපි front මේ first angle projection third angle අපි use කරන්නෙම නැහැ. textbook වල තියෙන්න පුළුවන්. මොකද textbook ගොඩක් ඒවා USA තමයි authorsලා ඉන්නේ. දැන් මම මේකේ දැම්මට මෙන්න මේක. මේකේ ගොඩක් ඒවා තියෙන third angle projection. හරිද? එතකොට මේ textbook බලනකොට පොඩ්ඩක් කල්පනාවෙන් ඒගොල්ලෝ views place කරන්නේ third angle projection. USA නිසා. අනිත් අය first angle.
okay sir.
හරි. අනිත් ප්‍රශ්න තියෙනවද මොකද views place කරද්දී? ඔව්.
ඒතන මේ A එකයි B එකයි අතර දෙන්න දුරක් තියනවද? ස්ටෑන්ඩඩ් දුර?
නෑ. ස්ටෑන්ඩඩ් දුරක් නෑ. මොකද ඒක දැන් ඔයා හිතන්න මම මෙතනින් සෙන්ටිමීටර් 10ක් තිබ්බා කියලා. හරිද? හැබැයි මම ස්ටෑන්ඩඩ් එකක් කියලා හිතාගෙන 10ක් තියලා මගේ පාර්ට් එකේ ෆීචර්ස් ගොඩක් තියෙනවා නම් මගේ ඩිමෙන්ෂන් එනවනේ මෙහෙම ගොඩක්. මේ පැත්තෙනුත් එනවා. හරිද? එතකොට මෙතන මේ මගේ ස්පේස් එක අඩු වෙනවනේ. ඒ කියන්නේ මට දැන් කොහොම ඩිමෙන්ෂන් ටික දාගන්න බැරුණොත් ප්‍රශ්නයක්. ඒ නිසා තමයි රෆ්ලි කැල්කියුලේට් කරගන්න ඕනේ ඩිමෙන්ෂන් කීයක් මේ පැත්තට එනවද. මේ ඒ අන්තිම ඩිමෙන්ෂන් එකේ ඉඳලා අනිත් ඩිමෙන්ෂන් එකේ කෙරෝලම එකට කොච්චර ඉඩක් තියා ගන්නවද කියන්නේ. ස්ටෑන්ඩඩ් මෙච්චරයි කියලා එකක් නැහැ. හැබැයි ඩ්‍රොයින් එකේ මේ views ටික ගන්නකොට මේ දැන් මෙහෙම නම් ඩ්‍රොයින් ෂීට් එක වෙන තැනක මේක අපි හිතමු ඩ්‍රොයින් ෂීට් එක කියලා. එතකොට මේ views ටික දැන් මේ කොහොම ළඟ තිබිලා ඊටු ටික නිකන් තියෙන්න බෑ. මේවා evenly space වෙලා තියෙන්න ඕනේ. මෙයා ඔයාගේ ඩ්‍රොයින් එකේ මේ මෙහෙම ඇවිල්ලා තියෙනවනේ. ඒ කියන්නේ ඔයාගේ ඩ්‍රොයින් ෂීට් size එක වැරදි. ඔයා අරන් තියෙන ලොකු ඩ්‍රොයින් එක. එක්කෝ ඇඳලා තියෙන ස්කේල් එක වැරදි. එක්කෝ ඔයා normally අපි 1 to 1 අඳින්නේ. එහෙම නැත්නම් ඔයා අඳින්න ඕනේ ඊට වඩා ලොකු ස්කේල් එකකින්. views ටික evenly space වෙලා තියෙන්න ඕන. දල වශයෙන් මේක දශම ගානටම හරියන්නේ නැහැ. practically කරන්න ගියාම manual drawing එකකදී. roughly බැලුවාම evenly කියන්නේ මේ roughly මේ හැරි ඉඳන් මෙතනට තියෙන space එකයි මේ අතර තියෙන space සමාන වෙලා තියෙනවා. roughly dimension දැම්මම මේ space එක අඩු වෙනවා. ඒක හරි. හැබැයි dimension overlap වෙන්නත් බෑ. ගොඩාක් ළඟට එන්නත් බෑ. මේ පැත්තේ dimension ටික මේ ළඟට එන්නත් බෑ. ඒ නිසා තමයි මේ පැත්තෙන් දාන එක වඩා හොඳ. මේ ටික ඒවා මේ පැත්තට දාන්න. මෙතන ඒවා මේ පැත්තට ගන්න. දකුණට. හරිද ප්‍රශ්න? හරි.
හරි සර්.
So next I have given you some pages in the textbook, right? So there they describe how to place the views, right? So you can read it. This note I got from my university when I learned this engineering drawings. So you can refer that as well. So this instruction varies from author to author in the textbook, but you have to get a general idea. So any questions on this lecture today? Any questions? No. So everything is clear. Okay. So I will give you another assignment on manual drawing. Right? So I will give you a simple part like this, and then you have to draw it on a paper and take a photograph and upload into the LMS. So I prefer you do manual drawings, then you know how to do it exactly, right? When you do it in the software, AutoCAD or especially in SolidWorks, you do not learn. You just blindly get the views and place it, right? So that's not good. So do it on the paper. So in the final exam also you will get a manual drawing, smaller one.
Hello sir.
Yes.
Sir මේ එතකොට අපි දැන් අඳිද්දි මේ එක අඳින්න නිකන් A4 sheet එකේද?
මේකද මේ assignment එකේද?
ඔව් assignment එකේ.
ඔව් assignment එකේ මම A4 එක දෙන්නම්. මේ A3 දෙන්න බෑ assignment එකේ. මේ හැමෝටම A3 හොයාගන්නත් අමාරුයි. ඒ කියන්නේ ඒක අඳින්නත් drawing sheet එක ලොකු නිසා මේ A4 එකක අඳින්න පුළුවන් වෙන්න එකක් දෙන්න පොඩි එක.
A4 එකනේ.
එතකොට මේ ඔයගොල්ලෝ drawing sheet format එකක් ඇඳලා තියෙනවනේ. මේ එතකොට ඒ sheet format එකේ print out එකක් අරගෙන ඒකේ මැදට place කරගන්න පුළුවන් මේ views ටික. cage එක අලුතෙන් අඳින්න ඕනේ නැහැ. cage එක ගන්න ඔයගොල්ලෝ දැන් assignment 2 එකේ ඇඳලා තියෙනවනේ cage එක. එතකොට ඒක fill කරන්න තියෙන්නේ. cage එක print out එක තියෙන කොලයක් ගත්තා. ඒකේ මැදට views ටික දාලා dimension ටික දාලා එවන්න. හරිද?
ඒ කියන්නේ මේ දැන් අපි ඔය අර AutoCAD වල layout වල තියෙන එක print out එකක් අරගෙනද මේ අඳින්න ඕනේ? ඒක ඇතුලේ.
ඔයාලට ඔප්ෂන් දෙකක් තියෙනවා. එක්ක අතින් අඳින්න පුළුවන් ඔක්කොම මේ cage එකේ ඔක්කොම ටික. ඒක ටික වෙලා යන වැඩක්.
ඔව්.
මේ මට මේන් අයිඩියා එක තියෙන්නේ මේ ඔයගොල්ලෝ views ටික හරියට ඇඳගන්න එකයි place කරගන්න එකයි. ඒක බලන්න නිසා තමයි මම කිව්වේ මේ අර cage එක print out එකක් කරන් ඒක ඇතුලේ අඳින්න කියලා.
ඒකත් ඒ gauge මේ version එකකින් version එකට මේ වෙනස් වෙන්නේ නැද්ද?
මොන cage එකද?
ඒ නර මේ තියෙන layout එක මේ template නේ.
නෑ ඔයා assignment 2 එකේ මම drawing sheet format එකක් අඳින්න කිව්වනේ.
හරි හරි ඒ format එකෙන් නේ.
ඔව්. ඒතර ඒවට මම කියලා තියෙනවා ඔයගොල්ලන්ට A4 A3 දෙකටම landscape portrait දෙකටම අදින්න කියලා. හරිද? ඒතර එන්න A format එකේ print out එකක් තමයි ගන්න ඕනේ. print out ගන්න විදිය PDF කරන විදිය කියලා දීලා තියෙනවා. අදින විදිය කියලා දීලා තියෙනවා. assignment 2 එකේ කට්ටිය submit කරලා තියෙන්නේ. ඒකේ print out එකක් ගන්න. මම assignment එක next week මැද විතර වෙදි දාන්නම්. පුළුවන් වුණොත් මම අද දානවා. මට වෙලා තියෙන විදිහට මම බලලා මේ ලේසි එකක් දෙන්න ඉස්සෙල්ලා. පැන්සලයි කවකටුවයි රූලයි කෝණමානිකුත් ඕන වෙයි. බේසික් ටූල් ටික. මට ක්ලියර් ෆොටෝ එකක් එවන්න මාක් කරන්න පුළුවන්. Any questions? තාමකුත් ප්‍රශ්න තියෙනවා. AutoCAD ප්‍රශ්න තියෙන අය කවුද ඉන්නේ? ඇක්ටිවේට් කරගත්තේ නැති අය හිටියා. එයාගේ ඇක්ටිවේෂන් එක හරියද දැන්? Okay. So
excuse me sir, SolidWorks software එක හොයාගන්න එකේ ප්‍රශ්නයක් තියෙනවා sir.
හරි.
මම සර්ච් කරා මට හොයාගන්න අමාරුයි මේ version එකක්. ඒ link එකක් මොකක් හරි තියෙනවා sir දන්න එකක් මේ
torrent වල තමයි බලන්න වෙන්නේ. වෙන option එකක් නැහැ. කරි torrent site එකකින් තමයි ගන්න වෙන්නේ. specific link එකක් නැහැ මා ගාව. බුද්ධිසයට මම කොපියක් දීලා තිබ්බා කලින්. lectures පටන් ගන්න කලින්. එයාගේ computer එකක් ඇති. කවුරුහරි ඉන්නේ ඒ කියන්නේ බුද්ධිසයට කතා කරලා සර් ඉන්නවනම් ගිහලා හම්බෙලා හරි එහෙම ගන්න පුළුවන්. මම දීපු එකක් ඇති. එහෙම නැත්නම් torrent site වල තියෙනවා. ඔයාලට Pirate Bay වගේ site එකකට ගියොත් SolidWorks ගන්න පුළුවන්.
so බුද්ධිසයට දෙන්න තියෙන crack version එකක්ද?
ඔව් මම crack එකක් දීලා තියෙනවා. full version නෑ. full version ගන්න නම් pay කරලා ගන්න ඕනේ. වෙන ක්‍රමයක් නෑ.
හරි sir.
crack version තමයි තියෙන්නේ. තාමකුත් තියෙනවද ප්‍රශ්න? Right, okay. So I want to go through this lecture content briefly. So we have like 10 days, and today is the 7th day. So I just want to go through this content roughly. So what we have done. So we did the introduction. So drafting equipment, sheet size, formats, type of lines. So lettering. So I'll do a brief one. So multi-views, we did the auxiliary views, sectional views. And breakout view, I will do it next week. So today we discuss about dimensioning and the dimensions, rules, components, symbols, so those kind of things. And next week I'm going to discuss about this geometric dimensioning and tolerancing. So we will discuss more about tolerancing next week, right? So if you have time, so do a little bit of research before come to lecture. What's tolerance? So if you have time, right? And then it will be good, because this geometric dimensioning and tolerancing is little bit advanced topic, but you will have to know this. So next days we will have to go through assembly drawings. So it's not that difficult since you do part drawings. So assembly drawings will be not that difficult. So we'll do a sheet metal drawing. What are the things we have to consider? Sheet metal drafting and welding process representations we do in the 9th lecture. And then so introduction to AutoCAD and 3D parametric 3D modeling in SolidWorks. We have started, right? The AutoCAD, most of the things we covered. So I just need to do some introduction on the SolidWorks. And final day, we'll do something about small time we'll allocate for the 3D printing as well. So that's how we define the content, right? So remember that in the engineering drawing, so there are many things you have to practice. Do it on paper and draw it. Every time draw it manually. Then you understand. Do 1 or 2 auxiliary drawings on the paper, right? Sectional views. So put the dimension manually, right? Do not just use the software only. Yeah. So those are my notes for you, right? If you really want to learn this subject, if you not consider this as an important thing, then you will suffer in the industry. So any questions before we finalize this lecture today? I can answer it now. No questions today. Okay. So I will upload the lecture to the YouTube and put it on the LMS, and then you can revisit the lecture again, right? Okay. So thank you very much.